What's up, AS Math? It's Mr. Knight. Today we're going to be looking at combinations of forces. But first, we are going to take a detour for a second. I promise this will be relevant. So, a company wants to find its net profit. It brought in $8,300 in revenue in 1 week, but it had costs of $5,200. Okay? So if we want to find the net profit of that, well, we know revenue is just like pure money just coming in. We know that costs, obviously that's subtracting money. So to get the net profit, we have to do 8,300 and subtract our costs. And then we end up getting $3,100. This guy is the net profit. So why am I bringing that up? Well, if we have a combination of forces, there might be forces, in nature there's lots of forces acting on us right now. We got gravity, we got the ground, we have air resistance if we're driving, we have braking if we're driving. There's a lot of things that go on. So if you're looking for like combinations of forces, you're probably going to have a net force, which means we're going to have to kind of revise Newton's second law a little bit. So net just refers to total amount. And we know that Newton's second law is F equals ma. But more generally speaking, we talked about this last time on Tuesday. Acceleration of an object is proportional to the net force applied. And so we kind of ignored that at first, but now with combinations of forces, we have to consider this F net equals ma. And we'll see how that works in a little bit here, okay? And obviously there's more than one force working on an object. So consider this for a moment. Let's say we got a book, one of those books that I was showing the other day, and let's say I have a rope tied around it, and I'm pulling with 500 newtons. And then Amelia comes along, and she decides, hey, I want to join in on the fun, and she puts her own rope on that, and we're pulling, but we're pulling at the same force. Is that object going to be moving? Well, if the forces are equal, it's not going to be moving at all, but we could see that mathematically a little bit more. So we know that if we're looking for the F net of something, that's going to be the force 1 plus the force 2. And if negative 500 plus 500, we end up getting an F net of 0. So, like I said, if the object's not moving, there's not going to be an acceleration. Okay, so our A is going to be 0. And objects with an F net of 0 are in equilibrium. So if you hear that word, your F net is going to be 0, and it's not going to have an acceleration. So if you have a lot of forces that are working on an object, it's a really good idea to sketch those forces and make it as simple as possible. So both of these diagrams show the same exact forces acting on an object. Both of these represent a plane. Obviously, one of them is more detailed than the other. And we got forces going on. We have lift, weight, we have thrust, air resistance, and it's accelerating. Okay? But this guy right here is actually a lot easier to draw, for one, and it's just a simpler idea, and you can still represent your forces just like this. So if it gives you like a car is having forces on it, or a train or a person, just turn everything into a box. You have that power in here, just turning things into boxes. And it honestly makes it a lot easier to work with, okay? So let's see that in action. Let's see with an example problem. Okay? This worked example is going to be on page 40. This is worked example 2.2. We'll start with part A. A car of mass 600 kilograms has a driving force of 500 newtons and air resistance of 200 newtons. Find how long it takes to accelerate from 10 meters per second to 22 meters per second. So let's draw our diagram and get a good idea of this. All right, car, I declare you a box. Okay? So we know it has a driving force of 500 newtons, so that's in the direction it's driving. And we assume this to be the positive direction, this to be the negative. And of course it's got this air resistance of 200 newtons, so it's kind of slowing the car down just a little bit. And then 600 kilograms for the mass. It's going to be accelerating in that direction. Okay? First things first, we need to find what the acceleration is. Well, we know F net equals ma. And F net is F1 plus F2 equals ma. Right? So we plug in what we know, so we end up getting, for our acceleration, 0.5 meters per second squared. That is not the answer. When I was making this, I accidentally boxed it in. So we need this guy in order to figure out how long it takes to accelerate from this to this. So we have an initial velocity, a final velocity, we have an acceleration, and we need to find time. So we want to use the Suvat equation. And so we're going to plug in what we know, and then we can solve for t. And so for t, we're going to get 24 seconds. This is the actual answer. This is a poser. Okay. But there's part B for this. So let's see what part B has to say. So part B says, all right, the car stops providing a driving force and the brakes are applied. It decelerates from 22 meters per second to rest in 220 meters. Find that braking force. So it's no longer applying that driving force, so we don't have that force in front of us anymore. We still have air resistance behind us, and now we have a braking force, and braking is resisting us moving forward, so it's actually also going back. So we have two forces working in that direction. So our box diagram can look something like this, and F subscript B is just representing our braking force. So if we set this up, we know F net equals MA. And our F net, this is negative 200 minus FB. They're both going in the negative direction. And that equals my 600, well, times A. We need to find what A is first. Okay? So we can do that, again, using a Suvat equation. We're going to use B squared equals U squared plus 2AS. So we know it's coming to rest, so that'll be the final velocity. Here's our initial. We know it was 220 meters, and this is going to just be A that we find. And we find A is equal to negative 1.1 meters per second squared. I figure you guys can do that part, so I didn't need to go through the steps. Just setting it up and figuring out what to use is kind of the more crucial element of this. So cool, we have our A now. We can plug it into this, and we can end up solving for FB. And once again, I figure you guys can do that. So FB will equal 460 newtons. All right, that's the video lesson today. Good luck on your homework. And if you have any questions, message me on Schoology if you're at COLA.